Howdy, today on Flippin Science we're talking about the periodic table. So the science understanding that we're going to look at is the arrangement of the elements in terms of atomic number and the trends. So we're going to look at the trends of atomic radius, valencies, and electronegativities. So first we're going to look at valencies. Let's look at the electron configuration for sodium, both simple year 11 version and subshell notation. If we look at both of them, we can see there's three main shells that have electrons in them. So here we have 1, 2, 3 shells. Here we have 1, 2, 3 shells. So that lines up with the period number. So period number 3, and that's where we find sodium. If we look at the valence shell, so that's the outermost shell, we can see it's got 1 electron in it for both in the simple and in the subshell notation, 3s1. So the outermost electron is a 3s1 electron, and that valence electron tells you the group number, so group 1. So if we look at sodium, its group number is number 1, because it has 1 valence electron, and if we look at its period number, that's 3 because it has 3 shells that contain electrons. Now we're going to have a look at electronegativity. So electronegativity is a measure of how strongly an atom pulls electrons towards it. So if an atom is highly electronegative, that means it's pulling electrons closer towards it, and if it has low electronegativity, that means it's not holding on to electrons very strongly, and that means it can lose electrons very easily. Electronegativity is important because it tells us how elements react and if they react at all. So we can relate electronegativity to metal and non-metal reactivity behavior. So the trend of electronegativity in the periodic table is electronegativity increases from bottom to top. So as we go up the periodic table, the electronegativity increases. It also increases as we go from left to right across the periodic table. Noble gases don't display electronegativity because they're neither pulling nor giving away electrons. So here are some questions. Which element is the most electronegative? What type of elements are highly electronegative? Which elements have low electronegativity? So if we look at the elements, we can see the electronegativity increases as we go left to right and from bottom to top. If we ignore the noble gases here, that gives us fluorine as our most electronegative element. If we look at the periodic table, our most electronegative elements are the nonmetals up here, and the elements with the lowest electronegativity are our metals over on the left-hand side and down the bottom. So this difference in electronegativity tells us how metals and nonmetals react. Metals don't hold on to their electrons very well, their valence electrons in particular, so they lose those in reactions, and that gives metal ions a positive charge. Non-metal elements gain electrons. They pull electrons towards them because they're very highly electronegative. So as they gain electrons, they get a negative charge. And this leads to ionic bonding, which we're going to talk about later on. So this relates to reactivity. Metals lose electrons in chemical reactions, and that's because they have low electronegativity. So they're not holding on to the electrons in their valence shell very well because they're not attracting them very well. So the most reactive metals are the ones that are the least electronegative. If we look at the nonmetals, it's the opposite. So nonmetals gain electrons in reactions, so the more electronegative elements gain electrons easier. So where do you find the most active metals? Where do you find the least active nonmetals? So if we go to reactivity, we can see its relationship to electronegativity. The most active metals, the most reactive metals, are the ones that are least electronegative. So they're on the left and they're down the bottom. So that would be francium. The most reactive nonmetals are the most electronegative. So they're on the right-hand side and at the top. So that gives us fluorine again. The last trend we're going to look at is atomic radius, and this is related to both electronegativity and electron configuration. So if an element is highly electronegative, it's pulling electrons towards it, and that means it has a very small atomic radius. So our nonmetals have small atomic radii because they're highly electronegative. They're pulling electrons towards them so they get smaller in size. As you go down the periodic table though, you're adding in shells. So you're adding in main shells for every period that you go down. And that increases the atomic radius because you have extra electrons surrounding the atom. So as you go down, the atomic radius increases. So our question is, what is the trend in atomic radius? So the trend in atomic radius is, as you go from left to right, the atomic radius decreases. So as you go from right to left, the atomic radius increases. And we're talking in a period here. So across a period, the atomic radius increases as you go from right to left. The atomic radius also increases as you go from top to bottom because you're adding in extra shells of electrons for every period you go down. So that's the trend in atomic radius. So let's just sum up those trends. As you go left to right and bottom to top, you increase electronegativity. As you go for metals, left and down, you increase reactivity. For non-metals, as you go right and up, you increase reactivity. And our trend in atomic radius is as you go left to right, the atomic radius decreases. And as you go from top to bottom, the atomic radius increases. So today on Flipping Science, we looked at some trends in the periodic table. That's it for Flipping Science today. See ya.